Okay, so I've got the controller board running, driving the SSR boards, driving same coil set up as Jason had in his videos. Some specs on it. Flyback diode on there to a scope that is floating ground with my EC600 power supply. And there's the input pulses. What I did was I raised the voltage up on the drive stage for the coil, and I got the resonant, the ringing up into the pulse. You can see boom, boom, boom. It keeps triggering itself. Okay. Now that little heartbeat there looks like this on the meters, and this is a DC power supply. So that's the load going through the SSR boards to the coil. So the magnetic field is going, in and out at a DC level. And this is what the sorry, it's so poor. That's what's on the scope. And you can see the scope has a beat to it also, and that beat matches the beat of the ringing up into the drive pulses. Sorry, it's so out of whack there, but I can smooth that out, I believe. And as you can see that little pulse there, I'll try to get in on that. Sorry, this camera's lousy. But that little fluctuation there in the time of that ringing of the secondary pulses showing up matches the beat that the whole system seems to be beating to. And that is the ringing ending up inside that pulse, or the main drive pulse. So if I lower the voltage, you'll see it all go back to, there, see? So there's a static situation, and you can see the FET ringing. If I raise the voltage up, boom, it ends up in the drive pulse. And so that ringing actually affects the whole system, where the drive pulse gets in phase with the ringing. And as you can see, most of the ringing disappears. And that beat ends up going through the whole system. And right now I've got this driving at I have it set up at 100 volts, but you can see it's hard to explain, that pulsating of the circuit is affecting the drive naturally, or the load on the FET. So sure, the drive is going to show, the load power specifications are going to show a fluctuation in there, because that's what's going into the FET driver. But this is basically a static system, and I've got this set up to run at 200 milliamps. I'm running at 1 milliamp. No, I'm sorry, it's 250, 10 milliamps. Fluctuating from 1 to 10 milliamps. That guy right there. So on the 200 scale. Now as I raise the voltage, I just get a higher magnetic field off the coil, and pulsating magnetic field. But that effect over there doesn't change. In other words, based upon the runtime parameters of this controller circuit and this SSR boards, you cannot get any more ringing to coincide with the pulse. Once you get there, you're done. It just starts oscillating itself. So on a DC setup with static DC pulses, you end up with this extra activity. Now, the coil's an air core, and it's not being read by anything or fed back into the loop of the operation. That could be something I could try next. Or I can put a reader off of that, reader coil off of that, Avermenko diode system, and see if I can put that to a scope and read that and see what's going on there. Or you can see that the EC600 holds up quite nicely to this. You can see it's almost faulting for triggering into a fault, but it's not. It's a good little box. Very, very high voltage, 4,000 volts, 200 milliamps max, so it's quite safe. But anyway, this is one of the things that I had gotten to before, and now I got the setup to continue on. So if anybody's got any ideas or any kind of advice or any kind of additional changes to this, I'd welcome that. Because what I want to do is I want to get that. This is going to be tough. I want to get that pulsating beat. Look at that. Boom, boom, boom. It's like once every 3/4 of a second. And I want to get that fluctuation there on that scope. Barely see it. To drive those guys. To drive those primaries. Now, one of the next things I'm going to do is take and put one of those primaries in series with that air core. It's all air core, okay? And so I'll be able to then add very, very little inductance, probably huge capacitance for the voltage I'm running at, and see if I can maintain those operating specs with that extra coil in series. It's not really a coil. I mean, it's a typical standard Tesla primary. And the ohmage is 0.01 ohms. Very, very small henries. And I haven't even tried the capacitance yet, but that's next. So that's what I've got for this, adding to this setup next. And as you can see, the system has stabilized itself for some reason. It's not oscillating anymore. And you can see the ringing is out here, see? Oops, let me get over there. The ringing is out there now. So what I'm going to do, I'm going to raise the voltage and bring that ringing up into the pulse wave. Nope. Now it's in there. There we go. There we go. It doesn't take much there on the drive side, or the FET driver side, to really make the scope over here, with this little scope, really jack. The signal goes from what I can see, from 45 to 60 volts. Boom, up and down, up and down. And this little oscillation there, I don't know if you can see it. I wish I could get a macro into this. This is not the best camera. See if I can get in there. It's cloudy, I know, but you can see there's a little subpulse down there. And it's tweaking back and forth in time as the pulsation goes vertically. Pulsation goes higher in voltage up, and this time distance goes further out. So there's this other artifact that I pointed out to before that Peter had said that he had seen also and disregarded it. But that's, to me, that's very important. And so this is not fluctuating as much. I crank this up to... I have no idea what voltage I'm running at. Yeah, so I'm sitting there at driving it with oops, sorry. Let's see here. 300 volts. 9 watts. 90 milliamps. Not much at all. And see, it's stabilized again. And even though the coil load side has stabilized for the power supply, and the driver, the FET input drive side is stabilized, the little scope is still jacking away. Let me see. I wish you guys could see this. It's fuzzy, but you can see the... I wonder if I turn the... I illuminate the screen. What do you see now? Nah, nope, that's very hard to get. This is a 25 megahertz scope. It's quite slow for the nano pulses that I'm putting in. But you can see it jacking up and down. I'll hold the real still so you can see that. So this thing is I'm getting a secondary ringing in the whole circuit without any feedback loop yet. And on the FET drive side, input side, let's see if this back out. There we go. Just a little bit. That little bit on the red causes 20 volt swing on the output with very minor fluctuations on the electrostatic power supply. The thing was banging before, but not much anymore. So there's some effect going on here that might prove to be interesting when the secondaries, let's see if I can get them here, when the secondaries of the my Tesla coils are actually resonating, and then I'm putting this extra beat in there also. We shall see. That's all for now. Leave any questions or answers or any kind of hypothesis when you can. Thanks. There's the specs. There's the specs. I'm on the driver's side. 100 nanosecond delay. 50 nanosecond pulses. The delay, I got to bring the delay down further. That'll be a next test.